So what you just saw is the realization of the HireMe Engine's newest custom feature, drop-in, drop-out controller support. This feature is accessed within Lua via these API functions. We've got connect player to controller, disconnect player from controller, get controller ID by player num, and get number of connected controllers are all new for this week. Basically what these enable a person to do at runtime is to connect via their own management any number of players to any number of controllers connected to your keyboard or your computer. So to demonstrate, I have a couple of controllers here. So when first the game gets running, the only character connected, because I don't have any controllers connected to my computer right now, is the one controlled by the keyboard. And we can see, completely controlled by the keyboard alone. Showcasing the custom particle system right there. Thank you, Jumpman. So let's add some controllers. An obvious one would be this made for PC X input controller, the SN30 Pro. Fantastic controller, and as you can see, we've got another Mario. Keyboard Mario is still controlled by the keyboard alone. Controller Mario, completely controlled by this controller. Let's get some more controllers in here. Still contemporary, we've got a Nintendo Switch Pro controller. Plug this in just with USB. Plug them in, and there we go, we got a third Mario. Let's go back through the ages, shall we? Here's the Wii Classic controller connected to an actual Wii remote. I've got a dongle here to plug it into my computer. And we've got another Mario. Now because of the way this dongle works, there we go. Now we can control them. And we're not quite done with our Nintendo history lesson here because I also happen to have a GameCube controller. This is also connected to a separate adapter that makes it recognize as an X input controller. And there we are. Another Mario. There is no cap. 5 is just the number of controllers that I have here. My Wii U Pro controllers are all at home, so this is what we've got. But as you can see and as you saw in the demo, everyone is independently controlled by their own controller. There is no overlap happening here. All of them can have their own animation controller. The only thing that every individual instance of this player needs is a new and unique player number. If you have that within the gameplay code, everything else is taken care of by the engine. Of course, I do have to show you controller disconnecting. If ever a controller disconnects from the computer, it'll send an event to the gameplay that controller has disconnected, and as you can see, that Mario has disappeared. This works for all of them. We can even reconnect the controller at runtime. Connected, and there's Mario. Now this Mario can be controlled. I was on OBS. If we restart, you'll see everyone connected is still connected. All 5. First, I figure I'll show you the APIs within the Lua code, and then I'll show you how it all works in C++. The main workhorse behind all of this working is this Game Manager class. It's very important to keep track of what players you've already added, because if you try to add duplicate players, you'll get multiple players connected to the same controller. That's all on the gameplay side. It won't crash, but it won't do what you want. So we established at the very beginning of the Game Manager class our first player num, and we keep track of our players within a players table. You can do it whatever way you want. This is just the way that made the most sense to me. And so for every 2 on the board, it's going to spawn a keyboard controller with the player attached to it, so you can control potentially infinite Marios with just the keyboard, or using the get number of connected controllers function, we can instantiate as many players as there are controllers. That's how you saw at the beginning of reloading the scene. All of the players are added again by attaching the keyboard controls component to the players. You can see that on start, the player connects themselves to the controller with the player number that was passed in for them by the Game Manager class, And on destruction, if the player were to be removed, or say the scene is reloaded and the player is deleted, it'll automatically disconnect itself from the controller via on destroy. This isn't imperative, this isn't the only way to do this, but this is a handy way to do this using just the on destroy function. We also have new controllers being added connected up to the event bus from C++. So when a new controller is connected to the computer, it'll actually send an event through the event bus using the same API as Lua called controller connected. We can subscribe to it like so, right at the end of on start. Yeah, you can see it subscribes to the controller connected event. We can also subscribe to the controller disconnected event, hook it up to a Lua function as usual, and with these functions we will receive the access to the data of the controller, and we can decide what we want to do with that at runtime. In this case, when we disconnect a controller, we want it to figure out if that controller was already connected to a player, and if so, we want to remove that player and destroy the actor, which will then free up the controller to be added to a different player. Or if a new controller gets added at runtime, in this case, we want to add a new player. Let's see how all this works. So in input.h, the only thing that's been added to the controller struct is a new player num. It's -1 when it's not connected to anyone, and it'll be equal to the number passed in from Lua when it is connected to a player. And of course, by doing it with this player system, if you do want to have some sort of game where you've got multiple controllers connected to the same player or the same object, you totally can. You just pass in the same player number. No new data structures really needed to be added, except for this one. We've got unconnected controller IDs. This is basically just to keep track if the player hasn't pulled for a controller yet, if they haven't tried to connect anyone to them yet, we want to know which ones don't have anyone. It's just an accelerating structure so that we don't have to go through all of them. The way that this works, we have a couple new states in the switch case of the event loop. Basically, when the new controller is added, when SDL detects that, we'll call add controller, and we will send a controller connected event. And when a controller is disconnected from the computer, we get the SDL controller device removed case, and we will do some things with the data structures that I don't feel like going into, and send to the event bus the controller disconnected. By doing this, of course, we do make controller connected and controller disconnected sort of restricted events. We don't want users to be using those, but unlikely that these are going to become names of events. The way that event function works, it creates a Lua event object containing the relevant information, just what player is already connected to the controller and what is the ID number of this controller, and we publish the event to Lua just directly through the event bus. Additionally useful to show is the add controller function. So this one has to handle a lot of SDL's stuff. Basically, we get a new controller from the event passed in by the SDL event loop. We check if it is a game controller, we check if it is open, or we make it open. If we've successfully opened it, then we can add it to the controller's data structures. Additionally, this week, unrelated to input, there were a couple other things that are worth mentioning. Rendering has been sped up immensely. You won't be able to tell via the frame rate counter on my computer right now because OBS throttles my computer's processing power, but I got it from like 47 frames a second to a consistent locked 60 by implementing some more aggressive culling behavior into the rendering loop. And the only side effect of this is that the order at which a camera is placed in the hierarchy versus everything else does matter. If you want everything to update frame 0 as soon as it happens, you do need to put the camera first in the scene hierarchy. That said, it kind of leads to some cool trippy effects when you have some things updating before the camera and some updating afterwards, which could be used for certain games. So that sacrifice did massively speed up the rendering time, and I'd say it was well worth it. The other thing worth mentioning, collisions can now be masked. So if multiple colliders are on the same mask layer, you can actually have them not interact with each other. To show this off, everything is default on mask layer 0, but if I add, say, mask layer 1 to the players, where previously you saw them jumping around, hitting each other, bumping into each other, all of that, now when we start up the game, we've got our keyboard controller, you can still see working completely well with all the walls and stuff, nothing wrong. But if we connect up our controller and get a second player in here, you'll see that instead of bumping into the first player, it goes right through him. Completely impervious. One final thing worth mentioning that was added this week is a new Lua API function, which is get time, basically to create like the frame per second counter in the HUD. I wanted to be able to get the current time, and so I did that. So it works with C++ Chrono. It's not particularly fascinating, but it does enable some pretty cool stuff.